Today, we will be looking at solving quadratics. Our objectives for today will be to understand how to solve a quadratic graphically, to understand how to solve a quadratic mathematically, and to understand what an x-intercept is. Our vocabulary for this lesson is as follows. We'll be looking at quadratic functions, which are functions where squaring is the largest exponent. We'll be using the real number system, which is all rational and irrational numbers. An irrational number is a number that can't be written as a fraction, and a radical expression is an expression that contains a square root symbol when simplified. The first thing we're going to look at is how to graphically solve a quadratic. This right here is a quadratic in the vein of what we've been using so far. It is in what we call vertex form, and we will dive more into that in the next video. To solve this graphically, we first need a graph of the equation. So to do that, we need a table. Because this is in the form that it is, I know that the vertex lies at the point of 1, which gives me numbers 0 and -1 to the left and 2 and 3 to the right. Because this is a quadratic, it will map to each other or mirror to each other, meaning that 3 and -1 will have the same answer because they're the same distance from our vertex at 1. So, to make this simpler, I will do math for 1, for 2, and for 3. 2's answer will be the same as 0. 3's answer will be the same as -1. One minus 1 is 0. 0 squared is 0. Subtract 4. We get our answer of 1, giving us -4. I'm going to rewrite this using 2. 2 minus 1 will give us 1. The square of 1 is 1. And 1 minus 4 is -3. Because 2 and 0 are the same distance from our vertex, 0 would give us the exact same answer. Then I'm going to do this with 3. 3 minus 1 gives us 2. 2 squared gives us 4. 4 minus 4 gives us 0. Because -1 is the same distance from 1 that 3 is, we would get the same answer. Now we're going to go ahead and graph this and look at how we can solve. Here I have a coordinate plane. I'm going to go about graphing our parabola, or our quadratic equation. -1, 0. 0, -3. 1, -4. 2, -3. And 3, 0. And we have our parabola. Vertex at 1, -4. When we are solving using a graph, what we typically do is we will be told what we're looking for. In this version, we could be looking for y equals 5. Well, if we're looking for y equals 5, we go to 5 on the y-axis, and we would have two possible answers, a negative and a positive. One of the problems with using a graphical way to solve something like this is it's all an estimate. I'm estimating as I graph, and I'm drawing my curve, and I'm estimating where these answers end up being. In this one, it looks to be very close to -2. In this, it looks to be very close to 4. Graphically solving works. It's just an estimate. Instead, let's now look at how we would mathematically solve. We would take this same equation and we would work from y being 5. We would substitute 5 in for y, and we would solve the equation. At this point, we would have to square root. This is going to give us 2 answers, hence the reason there were 2 answers in our graph. A positive 3 and a negative 3. In this version, we found that a y value actually has these 2 answers, exactly x of 4 and exactly x of negative 2. Graphically, we came close to those answers. We had about 4. We had about negative 2. We are just short of those values. This is the difference between the two. One being an estimate, unless you have a computer or a graphing calculator doing the graphing for you, and one being more accurate. Now let's look if it doesn't come out perfectly. So instead of 5, we're going to go with an answer of 8, a y value of 8. We're going to add 4 to both sides. We're going to square root. Now at this point, we have the square root of 12. If we get our calculators out, we will find that that is an irrational number. Because of that, we're going to leave it as a radical expression. We have square root of 12 equals x minus 1. And we have the negative square root of 12 equals x minus 1. We're going to add 1 to both sides and get the radical expression of square root of 12 plus 1 equals x, and negative square root of 12 plus 1 equals x. We now have a radical expression. We could get a similar estimate from a graph. The last thing that we want to look at is the fact that there are things called x-intercepts. X-intercepts are as simple as they sound. In the past, we have talked about y-intercepts, where a graph crosses the y-axis. An x-intercept is where the graph crosses the x-axis. In this case, right here at negative 1 and positive 3. We can mathematically find these by putting 0 in for the y value, because a root, or a x-intercept, has a y value of 0. Remember that if we miss anything or we're not sure about something, that we pause the video and go back. Thank you.